All right, so this is a beginner talk about using Pandas data types more effectively. So let's see, yes, I have a caveat. I am cheating. I'm pre-running these cells before the presentation. Let's see, we might have opportunity to rerun the cells later. But anyway, so Pandas, what are we talking about here? Pandas is basically the interface dealing with spreadsheets. You don't have as many limitations as in commercial products for spreadsheets. This feature is called Dataframes, and so it has a couple of differences between what spreadsheets are, but you can think of it as the row and column friendly accessing that you've done before. So these are the methods. I'm going to be importing pandas, a couple of other libraries to help us along the way. I'm, let's see, cheating as to munging some of the data before I get started. Let's see. But this is the mall sign that you're always looking for. This is the "you are here" part of the data science stack in Python. So we have Python down at the very bottom. We have a couple of helper libraries, let's see, low-level libraries that are able to deal with the data. Jupyter Notebooks are, let's see, is what I'm going to be using to give this presentation. Let's say NumPy deals with low-level calculations. Let's say we're going to be talking about Pandas, which deals with all of these three lower level, let's say the Numba, we're going to be using Jupyter, and it uses NumPy under the covers. So there's plenty more in the data science stack, plenty more to learn about. Let's see, if you want to deal with brains, if you want to deal with economics, if you want to deal with, let's see, biology, and then there's tasks in the data science stack for that. The lower that you go, the more that you need to know about computer science. The higher you go, the more you need to know about anything else. So anyway, I'm going to be using data from the data.sandiego.gov site. Today we'll take a look at some parking meters and some, let's say, pothole information. So let's take a look at that first 5 rows of this. We've got nice columns, and these are, we know what data types these are. So zone has city, so it's going to be a string. Area is Barrio Logan, it's going to be another string type. All of these, let's see, the config codes, it might actually read in as numbers, but how do we know that it brought these in correctly? So what I'm going to do is take a look at parking meters info. And we can be able to tell what type of objects it read these in as. So anytime you see object, it read it in as a Python object. It was of an unknown type to pandas. So they just brought it in and said, okay, let's see, we'll let Python deal with this thing. Int64, it knew exactly what that was. So that config code that we're talking about, let's see, the config name is an object. This is going to be, let's see, anyway, we're going to take a look at how to deal with some of these objects. Latitude and longitude, I mean, they got the float type. And it'll also tell you things like how much memory usage we've got. So we'll see this again in just a moment. So this config name, I'm going to separate out this config name all by itself. It's got way too much information to be useful inside this spreadsheet. So what we're going to do is split some of this up. And the way to do it, even with Python data type objects, is using this str type. It brought it in as a string. So .str, and it has these methods associated with it. Let's see, so all the normal string stuff, we can, let's see, turn it to upper, we can find out if it is an alphanumeric. And so we can do uppercase, and this is going to change the value inside here. So let's take a look at that value. Might need to rerun. Sorry. No. So now everything's in uppercase. There is a way, if you do something like a string dot split. Now what happens? So let's take a look at. Oh, did it again. I messed it. So restart and run all. Okay, so now this is not no longer a string. It's stuck in a list. And you get the idea that you need to iterate over this. And let's say with a for loop or something like that, to be able to get what you want. Don't do that. Let's say, hey, we've got string accessor methods inside this. You can put on this, let's say, indexing right afterwards. So str 0 to 3. So I want to be able to get just this information. You can also do things like join it, or let's say .str.join, and using a separator. Let's say you can pick out any character you want, but let's say we can use -sign. And if you keep going, make these dotted notation even longer, we almost get to the point of Java. Anyway, so let's see, it's got other regex based string methods. So here's an example of find. I want to find out where the hour is. Let's see if I can run it. I'm going to go ahead and set that. Start columns. I've got my max time limit. I messed it up. Let's see. Oh, I did too many of these. Oh, I did run that one. So this. I do restarting and running all. The reason to restart and run all of these inside of a Jupyter Notebook, everything is run. Let's see, all of these, you'll notice the in8, in9, out9. It's saving all the inputs and all the outputs. So if you need to, you can get a fresh copy. So. Anyway, I might have to come back to that. So let's say you can do these regexes. It'll point to locations inside here. Let's take a look at pothole repair. With pothole repair, you can, all right, we're going to take a look at this date requested field. Let's see, did it bring it in properly? In this case, that date requested field is an object. So it didn't bring it in correctly to be able to use it. So let's change the data type using this PD2 date time, have the date requested, and take a look at the info now, and you'll see it brought it in as date time 64, let's see, with the nanosecond capabilities. So now that we have this new data type in this column, we have this .dt accessor method that we can attach onto here. And it will tell you things like the day of the week that people reported potholes. So we can do, let's say, hour of the day. No, or hours. Just hour, sorry. You can also change your date format. So if you don't like this particular date format, you can change it using striff time and bring it in that way.
Do those methods have autocomplete?
Yes, let's see. So I've just pressed tab and it'll pull up day of week, day of year. So let's pull up day of week. Now it looks like this. Let's see, how about value counts dot plot dot bar. Then you can find out, hey, people don't report as many potholes on the weekends. So okay, we're going to take a look at another column. This tells people, how did this website know about those potholes? So this one came in by phone, that one came in by the website. So let's take a look at that particular object. It is of type object, and so we need to change this to a type called category. What this is going to do is it's going to save a lot of memory. Let's see, now we can see that it's been changed to this category type. So let's delve into what it's doing in the background here. The category, it has some categories that it found. It found these, what is it, 10? 9 or 10 categories. So it's associated now in the table with a number. So each one, 0 through 9. So we can take a look at the categories. We can take a look at the codes that it's associated with. Now, if you change one of the labels in this categorical, it just changes it in that one location, and the numbers all stay associated with it. So here's an example. We're going to take a look at the sparse data type as the last one. The sparse data type in this case has, I'm looking for is not a number. There's 31,000 not a numbers in this. So let's take a look at the type right now as a float 64. And I'm going to change it to that. We're going to change the type first, because that needs to happen with most of these, to a sparse data type. And let's take a look at the info now. So this gets a sparse data set with this. It didn't save all that much memory-wise, 662 kilobit versus 623 kilobit. Let's see, but that might be the nature of this particular column. It doesn't have, let's say, you usually want to have this type of column whenever you're 10% or less. So that would be sparse. There's more sparse and whatnot. So, but there's accessor methods on this one are going to, let's say the methods are related are things like fill value, endpoints, the number of items that are not null. And you can get a density ratio. So it was 62% full. Anyway, so let's see, takeaways are first convert the column that you want to use that type. Then you can use these string accessor methods. Then you have these groups of functionality. So this is a talk to try and move you away from using the word apply. Apply is the granddaddy of all of the items. You can put a lambda in there and make it do what you want, but those are slow because it doesn't know what data type you're passing in. And so it has to figure that part out before it can actually work on it. So anyway, I'm going to take a look at chat and see if there's any questions. Oh yeah. String.split explode is true. I got to try that one out.
Were there any questions? I don't see any in the chat, actually.
I just
Oh, here's one, actually. One just came in. When is it prudent to convert a data column to a sparse type?
Let's see. You want to, or whenever your data is actually sparse and you're looking to save memory. So you have more nans than actual values. Let's say your customer table has social security number in it. You have no reason to be able to save their social security number. Now let's say maybe you're in and out. Then let's say your social security number is going to column is going to be pretty sparse. So you can save a lot of space by casting it in this sparse type.
What would be a good threshold for using a sparse type?
I would say 10%. I would, let's see, you can save some memory by, let's see, this particular one had 62%. I ended up saving a little bit of memory, but it's not really all that useful whenever you have a lot of values, when you have a larger value to non-value ratio.